Hello everyone. So actually today we are going to see learn about optional. So before anything we start about optional, let's see first what is variable, because we should understand first variable, then we can better understand why we use optional in Java 8, which is got introduced under java.util package in Java 8 release. So let's start. Variable, as I show here, variable is nothing but a container inside which is it is useful to hold any value. Like let's say I have variable of type int, then it will hold some integer value like 25 here I have mentioned. So when in program we let's say it's a part of a class and we have created object of it, and we are trying to access that variable value, then what will happen if that variable has assigned some value, we have stored some value, then we will get the value like let's say for example 25. Then if we access it, then we'll get that value 25. But uh, without knowing, or let's say that variable is currently don't have any value inside that, so it might have the value as a null assigned to it. Then at that time, if anyone try to access that variable without checking the null, means in a program, during the flow program, it may happen sometimes the variable doesn't assign any value, then it assigned to the null. That time, if we have some statement where we are accessing that variable, then what it will gives, it will gives us null pointer exception. Okay, so this is a kind of a nightmare every programmer face when they have built some applications and the application is got crashed because of these null pointer exceptions, errors, and it's not able to proceed further. To avoid such null pointers crashes, due to null pointer the program crashes, Java 8 introduced optional as a feature in a Java 8 release. So let's see one more example. Okay, now we'll see what is optional. So as I mentioned here, I just optional is nothing but encapsulation, a standard encapsulation around a type T, where T is a data type, like any data type. We can encapsulate that data type, any data type variable, eh, standard encapsulation, which is known as the optional. So then what will happen, as we see in the previous example, let's say we have variable, again it holding some value like integer variable 25, and also we will have an encapsulation around it. Like you can see here, there is a one more layer around that variable, which is the optional layer, we can say. And that time if we are trying to access that variable in somewhere in a program, then what will happen, then internally it will verify whether any value presence and absence of any value. In short, optional will check before accessing directly the value, it will check whether the value is present or not, and depend on that, if value is present, then it will return the value. Like here 25 will be get returned. With the context of this concept, let's say the second scenario, the variable is assigned to null. That time what will happen, definitely again we know there is a optional encapsulation layer around the variable. That time if someone is going to access somewhere in a place in a program, then again it will check the presence or absence of a value. Now it's a null, means definitely absence of value, there is no value. Then it, instead of throwing the null pointer exception, which is the problem for us we are facing, it will return empty optional, as I have mentioned here. Like, as it verifies null and return empty optional object, or there is an option that we can also able to return exception, means definitely it will return empty optional, which will definitely solve our problem of null pointer. But there is other ways also they have provided, like if we want to mention that there is a null value present, we can also uh, throw any user defined exception, that also there. So this is like I'll say core concept behind using the optional. So in this way it will work. Let's visualize one more example here by the picture I have, as I am showing here. um, we are taking now an example where optional is useful while programming. So let's see, we have mobile phone. Inside a mobile phone, let's say Android or iPhone, anything, inside that definitely will have OS. So if the mobile phone is Android, then we'll have Android OS. Then on then top of that OS we have different apps running on. Let's say we have a name of app 1, and then every app have their own version. Like, let's say for example here it's a version 1.0. And in a program we want to access all these layer through this layer, and want to access and get the version of app 1. Then how will get access, as given here the string, will go to the first, take the mobile phone object, then get Android OS object, then get the app 1 object, like by layer wise as per architecture, then finally get the version. So how we can relate this? This is on a if we take if we are trying to build a classes from it, then we can relate it like a nested classes. Like, the most parent class will be mobile phone, which will contain object of Android OS class, then again which have its uh, variable, which again will contain object of its child class, that is app 1. And then app 1 class definitely will have a single variable like type of string, name as a version. Okay, and then we will trying to access it. Now uh, let's we now discuss that example as we have seen in a picture, that picture in a program now. So I have already created that nested layer of classes. Like, we have mobile phone class, and it's a non-optional example. Like, normally without optional we have created the classes. So as I was discussing, mobile phone class, the uppermost class, it will contains object for Android OS class, and then again this Android OS class will have variable of app 1 class, which is child class of this one. And then Android then app 1 class will have the final, the innermost variable, that is version. And I have created the getter setters for all the classes. uh, okay, through the layers how we are going to access them. Then let's say in the main method, as I have defined here, I have just created the object of the most parent class, that is mobile phone, and then I'm trying to access the version like mobile phone dot get android os obj dot get app 1 obj and then dot get version. uh, I'll try to run this now. As you can see, we got the null pointer exception as we expected. But let's go with the fair play and add the required like say instances. Let's create the instances and let's see what will happen. Let's say we'll have here assign the version, this dot version equal to 1.0, and here we'll create object of new app 1, and here we'll create object of new Android OS, then return it. Okay, right, fair enough. So let's run again. I expect it should work fine. Yep, it is working fine, and we are getting the value of the version, that is 1.0. Okay, so let's consider now, as this is a layered structure. um, let's see if we'll come back to again our picture view. So let's say this, as this is a layer structure, let's say Android OS becomes null, or we assign the null value to the Android OS except the other layers. Then what will happen? Okay, so let's say here we assign value as null. Okay, and then rerun again. Again it's a null pointer exception. Means when we are trying to access even normal way or in a layered way, if the object is having null value, then definitely we are going to face a null pointer exception. Then the thing like a variable is becoming null or assigned by a null, it might be a dynamic way, like while the program is running in a flow and some situation or some conditions executed which causes it to get assigned to null, so that might happen. So we can't control over the program flow because it's executed against the different conditions and different uh, I can say paths depend on the inputs and interaction with the user. So to handle this unavoidable, or I can say the sudden null pointer exceptions which may cause the whole program to get crashed or get suddenly stopped, we have optional. So let's say how we can improve this code using the optional example. So here is my second class I have created, that is optional example. So where I have modified the class and created new version of the same structure but with use of optional. Let's say the class is first what I have created. So in this example I have taken example of same layers, just I just changed the my mobile phone to the iPhone. So again my parent class, most of parent upper parent class will be iPhone, which will be holding the object of Apple OS, that is okay. And then Apple OS further will be holding app named as FaceTime app. Okay, and the innermost layer of the FaceTime app class will be holding the value, string value, that is contact ID, that is some random string I have assigned. So definitely, ultimately, we will be trying to get the innermost value, that is the contact ID. Then let's say what will happen, as we have ensured that we will be using the optional. So as you can see, while creating the variable, I have wrapped around that or encapsulated. This encapsulation keyword is very much important. So I have encapsulated the variable around using the optional, as you can see. So there is one method that we can create a optional object for null values as well. As you can see here, optional of nullable, which will allow you to create object of null. And here you can say I have created the same way, like using the optional dot of nullable, but I have assigned the new FaceTime, which will definitely will be not null. Okay, so let's create here as well, because we can't assign directly null. Let's create object of Apple OS. Okay, and assign it here. Okay, okay, so like this will be creating the objects. So what what exactly mean this method is like, um, it allowing it, that it whatever object we are wrapping around, so that may be null or may not be null, but this method will allow to hold the null object. And when we are returning, if it is null, then it will return empty optional, as we have discussed earlier, instead of throwing null pointer exception. Okay, so let's quickly run our program again, as I already added the code here. So I'm just sys out uh, created variable for the most parent class, that is iPhone, and then I'm accessing its subclasses that get uh, Apple OS object, and then from that we'll get FaceTime app obj object, and then from that get contact ID and print it. So let's try to run it. Okay, as you can see here, we are getting our string in form of optional, which is good. Now let's see our use case, like one of the object becomes null, as I told. So let's make the middle layer null, like this Apple OS, because we have iPhone, inside iPhone we have Apple OS, and inside Apple OS we have FaceTime app. So let's make Apple OS as a null. So here we'll be assign null to FaceTime obj, which is getting return, and which again is used by iPhone. And now we are going to run it again, and let's see what will happen. Run option. Huh. Now you can see it's returning optional empty instead of null pointer exception, which is great. Means we are not saying that dangerous red colored error of null pointer exception. Instead of that, it's just an optional dot empty. So which is definitely good thing. It will stop crashing of our application and flow of our program. So it done its job very well to avoid a null pointer exception. Now you might think like, why we are using flat map here, and at the end map to access the values through the layers. um, like in normal class we just access it with dot operator and get it. So we will be see in why we are using this flat map in a upcoming video. It's just a small but important concept. We will be see that in our next video. So thank you for watching. If you like this video,